Okay, so now we are going to write here Bowley's measure of skewness. Bowley's measure of skewness. Bowley's measure of skewness. Bowley's measure of skewness. अब हामीसँग absolute measure र relative measure छ. सबभन्दा पहिले we are going to write about the absolute measure based on Bowley's. The absolute measure of skewness. Absolute measure of skewness based on Bowley's. Based on Bowley's is. The absolute measure of skewness based on Bowley's is skewness. Skewness equals to formula हामीसँग के छ Q3 minus MD, Q3 minus MD, then minus MD minus Q1. Okay, this is the formula. Q3 minus MD minus MD minus Q1. यसलाई हामीले अब अलिकति simplify गर्न मिल्छ. Q3 minus MD minus Q3 minus MD. Okay, so let's write here. Q3 minus MD, then minus MD अब plus Q1 हुन्छ. यो minus into minus भनेको plus हुन्छ. So we can write here Q3 MD minus MD भनेको minus 2MD we can write, then plus Q1. Okay, so what we can write here? This equals to Q3 plus Q1 minus 2MD. Okay, we found here therefore skewness को formula हामीले के find out गर्यौ त based on Bowley's. यो चाहिँ absolute measure of skewness हो. त्यही भएर skewness equals to Q3 plus Q1 minus 2MD. Okay, this is the formula for skewness. अब हामीसँग the relative measure of skewness based on Bowley's is based on the relative measure of skewness based on Bowley's based on Bowley's is. Oh, अब त्यसलाई भन्छ Bowley's coefficient of skewness. हो यसलाई के भन्छ त relative measure of skewness भनेको अब Bowley's coefficient of skewness. So let's write here Bowley's coefficient of skewness. Bowley's coefficient of skewness. Bowley's coefficient of skewness. Okay, it is denoted by हामीले यसलाई चाहिँ SKB भनेर डिनोट गर्छौं. SKB Bowley's coefficient of skewness भनेको SKB. This equals to यो भनेको अघि हामीले skewness को फर्मुला लेखेका थियौं. त्यसमै Q3 minus MD, okay, then minus MD minus Q1, divided by, अब डिवाइड मा हामीले प्लस यसको माइनस फर्म माथि लेख्यौं, हामीले यसको प्लस फर्म लेखौं. प्लस फर्म मा चाहिँ what we are going to write here Q3 minus MD, okay, then plus MD minus Q1. Okay, now let's simplify it. Let's simplify garda we'll get here Q3 minus MD, then minus MD minus Q1 divided by Q3 minus MD plus MD minus Q1. Okay, so here we'll get यहाँ त MD र plus MD minus MD plus MD we can cancel. माथि चाहिँ के आउँछ त Q3 minus 2MD minus Q1 or plus Q1, sorry, यहाँ plus Q1 हुन्छ है, plus Q1 then divided by Q3 minus Q1. So further we can simplify. Okay, यसलाई अब अलिकति अरेन्ज गरेर लेखौं. What we can write after this? यस पछाडी हामीले के लेख्न मिल्छ त Q3, write Q3 plus Q1 plus 2MD or minus 2MD. We get there minus 2MD divided by Q3 minus Q1. Okay. Therefore, हामीले के फाइन्ड आउट गर्यौं त? Therefore, SKB भनेको SKB को फर्मुला Bowley's coefficient of skewness को फर्मुला के हुन्छ त? Q3 plus Q1 minus 2MD divided by Q3 minus Q1. Q3 minus Q1. Okay, this is the important formula to memorize. यो चाहिँ हामीले memorize गर्नु पर्यो है. This is the important formula to be memorized. यो हो Bowley's coefficient of skewness. Bowley's coefficient of skewness को फर्मुला हुन्छ Q3 plus Q1 minus 2MD upon Q3 minus Q1. Okay, remember this one. यो सबै यहाँ क्वार्टाइलहरु छ. यो Q1 भनेको फर्स्ट क्वार्टाइल, मिडियन भनेको सेकेन्ड क्वार्टाइल, Q3 भनेको थर्ड क्वार्टाइल. त्यसैले this formula is also called, यो फर्मुलालाई के पनि भनिन्छ? This formula is also called quartile coefficient of skewness पनि भनिन्छ है. Quartile coefficient of skewness. यसलाई हामीले Bowley's मात्र हैन, यसलाई के पनि भन्छौं त? Quartile coefficient of skewness पनि भनिन्छ. This formula is also called quartile coefficient of skewness. अब यो यहाँ त हामीले फर्मुलाहरु यहाँ ड्राइभ गरेको, खास फर्मुला हामीले दुईटा पढिरहेका छौं. एउटा स्केवनेस को फर्मुला Q3 plus Q1 minus 2MD अनि कोएफिसिएन्ट अफ यो कोएफिसिएन्ट हुन्छ क्वार्टाइल कोएफिसिएन्ट अफ स्केवनेस और बाउलीज कोएफिसिएन्ट अफ स्केवनेस. त्यसको फर्मुला चाहिँ SKB = Q3 plus Q1 minus 2MD upon Q3 minus Q1 हुन्छ. ओके, ल अब यसको भ्यालु पनि कसरी कहाँदेखि कहाँ रेन्ज हुन्छ, that we are going to write here. Since the value of Bowley's coefficient of skewness ranges from यसको पनि भ्यालु -1 to +1 नै रेन्ज हुन्छ. Since the value of Bowley's coefficient of skewness ranges from -1 to +1 है, यसको पनि -1 देखि +1 सम्म रेन्ज हुन्छ. That is, त्यो कुरालाई हामीले कसरी लेख्न मिल्छ? -1 is less than or equals to SKB is less than or equals to 1. यसरी लेख्न मिल्छ है त. -1 is less than or equals to SKB is less than or equals to 1. अब यसमा पनि हामीले interpretation of calculated value of SKB यसको पनि हामीले interpretation गर्छौं. Interpretation of calculated value of SKB. Interpretation of calculated value of SKB भनेको Bowley's coefficient of skewness को भ्यालु पनि के हुँदा कस्तो हुन्छ भनेको that we are going to write here. If SKB को भ्यालु exactly 0 आयो भने the distribution is said to have no skewness. Okay, the distribution is symmetrical भन्न मिल्छ त्यसलाई. If SKB equals to 0, the distribution of data is symmetrical. Symmetrical भनेको no skewness है. Symmetrical भनेको no skewness. If SKB equals to 0, the distribution of data is symmetrical. त्यसैगरी सेकेन्ड नम्बरमा if SKB Bowley's coefficient of skewness is greater than 0 भयो भने the distribution of data is right skewed. Okay, is right skewed. The distribution of data is right skewed. अब थर्ड नम्बरमा हेरौं. थर्ड नम्बरमा if SKB is less than 0 भनेको Bowley's coefficient of skewness को भ्यालु less than 0 आयो भने the distribution the distribution of data is left skewed. यसमा हामीले के लेख्नु पर्यो त left skewed भनेर लेख्नु पर्यो left skewed. If SKB is less than 0, the distribution of data is left skewed. Okay. So this is all about Bowley's coefficient of skewness. यो चाहिँ Bowley's coefficient of skewness भयो. Now we are going to write about measure of kurtosis. So now let's start here. Measure of kurtosis. Measure of kurtosis. Measure of kurtosis. Okay, at first we are going to define this one. Measure of kurtosis भनेको के हो त? त्यो we are going to define measure of kurtosis. Measure of kurtosis, the descriptive statistical measure which is used to measure the flatness or piggedness of the curve is called measure of kurtosis. Is called measure of kurtosis. The descriptive statistical measure which is used to measure the flatness or piggedness of the curve is called measure of kurtosis. हामीले पहिले पनि के कुरा डिस्कस गरिसकेका छौं. Mean, measure of central tendency. Measure of central tendency ले represent गर्छ central value of the data. हो, measure of dispersion ले डाटा कति स्क्याटर भएको छ, सेन्ट्रल भ्याल्युबाट कति टाढा डिस्पर्स भएको छ, स्क्याटर भएको छ भन्ने कुरा चाहिँ मेजर अफ डिस्पर्सन ले मेजर गर्छ. मेजर अफ स्क्यूनेस ले शेप अफ द कर्व को मेजर गर्छ भने अब त्यो कर्व कति फ्ल्याट छ कति पिग्ड छ भन्ने कुरा चाहिँ मेजर अफ कुर्टोसिस ले मेजर गर्छ है त. कुर्टोसिस ले मेजर गर्ने भनेको त्यो कर्व चाहिँ कति फ्ल्याट छ कति पिग्ड छ त. दैट इज measured by kurtosis. Measure of kurtosis. Okay, so we are going to write here. अब यति लेखिसके पछाडी types of kurtosis. Types of kurtosis. Types of kurtosis मा there are three types of kurtosis. There are three types. There are three types of kurtosis. There are three types of kurtosis. They are. अब हामीले चाहिँ कतिवटा टाइप्स हो त कुर्टोसिसको. There are three types of kurtosis. They are. one नम्बरमा लेखौं मेजोकुर्टिक. Okay. The curve is said to be mesokurtic. यो mesokurtic भनेको चाहिँ के हो त? The curve is said to be mesokurtic. कति बेला mesokurtic भनिन्छ त? कर्व लाई कति बेला mesokurtic भनिन्छ? Okay, the curve is said to be mesokurtic if the curve drawn from the distribution of data is neither so flat nor so peaked. The curve is said to be mesokurtic. Okay, the curve is said to be mesokurtic if the curve drawn from the distribution of data is neither so flat nor so peaked. धेरै फ्ल्याट पनि छैन धेरै पिक्ड पनि छैन भने त्यस्तो कर्वलाई हामी के भन्छौं? mesokurtic curve भन्छौं. Okay, so if the curve drawn from the distribution of data is neither so flat nor so peaked भयो भने त्यो बेलामा mesokurtic curve. Okay, it is also called moderate type of curve or normal curve पनि भनिन्छ है. normal curve पनि भनिन्छ. It is also called moderate type of curve or normal curve. Okay. Now, यसको हामी अब के गर्छौं त? We are going to draw here curve draw गरौँ. त्यसमा हामी 3 types of curve नै एकै पटकमा draw गर्छौं. हेरौँ है. Okay, so now let's draw here curve. Curve draw गरौँ. Okay, this one is x prime x. Here this is y prime. The curve draw गरौँ. सबभन्दा पहिला I am going to draw here normal curve. Normal curve भनेको, okay, suppose this is a normal curve. यो एउटा normal curve हो, neither so peaked not so flat. Okay. अब normal curve, अब यो भन्दा normal curve भन्दा बढी peaked छ. Okay, normal curve भन्दा बढी peaked छ. अब माथि त यस्तो खालको छ भने this is the यो normal curve m भनेको normal curve हो भने यो curve लाई हामी leptokurtic curve भन्छौं. Leptokurtic curve. Okay. र अर्को अब फेरि यो normal curve भन्दा यहाँ mesokurtic curve भन्दा अझै के छ त? सपोज हामीसँग फ्ल्याट छ. फ्ल्याट भनेको अब यतिबाट यस्तो. Look at here. यो फ्ल्याट छ भने यसलाई हामी platykurtic curve भन्छौं है त. Platykurtic curve. यहाँ मैले 3 types of curve लेखिसकेको छु. यो भनेको L भनेको चाहिँ leptokurtic curve हो, M भनेको mesokurtic curve र P भनेको चाहिँ platykurtic curve. So otherwise you can write here, right? यो L भनेको चाहिँ leptokurtic यो leptokurtic हो. M भनेको चाहिँ mesokurtic. Okay, यो चाहिँ mesokurtic. P भनेको चाहिँ platykurtic भनेर लेखौं. P भनेको चाहिँ platykurtic. यसरी L भनेको leptokurtic, M भनेको mesokurtic र P भनेको चाहिँ platykurtic. Okay, so अब यसको चाहिँ हामी लेख्दै जाउँ. यो mesokurtic we have already written. Now let's write about the leptokurtic. 2 number मा लेख्दै छौं अब leptokurtic. So let's write in 2 number. 2 number मा leptokurtic. Okay, leptokurtic. The curve drawn from the distribution. The curve drawn from the distribution of data is said to be leptokurtic. Is said to be leptokurtic curve. The curve drawn from the distribution of data is said to be leptokurtic curve if it is more peaked. If it is more peaked than the mesokurtic curve. अब हामीले with reference to mesokurtic curve define गर्न छौं है. With reference to mesokurtic curve. Mesokurtic curve को reference मा यसलाई define गर्यौं. The curve drawn from the distribution of data is said to be leptokurtic curve if it is more peaked than the mesokurtic curve. यहाँ हेरौं. mesokurtic curve भन्दा पनि माथि छ अझै. peaked बढी भएको छ. बढी peak छ यो. भने that is called leptokurtic curve. Okay, so the leptokurtic curve पनि भयो भने अब थर्ड नम्बरमा हेरौं. platykurtic curve. Platykurtic. Okay, platykurtic curve. त्यो भनेको चाहिँ the curve drawn from the distribution. The curve drawn from the distribution of data is said to be platykurtic. Is said to be platykurtic if it is more flat. If it is more flat than the mesokurtic. If it is more flat than the mesokurtic curve. Okay. The curve drawn from the distribution of data is said to be platykurtic if it is more flat than the mesokurtic curve. मेजोकोर्टिक कर्व भन्दा पनि अझै फ्ल्याट भयो। हेरौँ, लेप्टोकोर्टिक भनेको मेजोकोर्टिक भन्दा पिक्ड हुन्छ, बढी पिक्ड हुन्छ। प्ल्याटिकोर्टिक भनेको मेजोकोर्टिक भन्दा के हुन्छ त, अझै बढी फ्ल्याट हुन्छ है त। फ्ल्याट हुने हुनाले त्यसलाई हामी भन्छौँ प्ल्याटिकोर्टिक। ओके, सो दिज आर द टाइप्स अफ कुर्टोसिस। टाइप्स अफ कुर्टोसिस। टाइप्स अफ कुर्टोसिसमा हामीले के पढ्यौँ त, मेजोकोर्टिक, लेप्टोकोर्टिक, प्ल्याटिकोर्टिक। ओके, सो दिज आर द टाइप्स अफ कुर्टोसिस। अब हामी मेथड्स अफ मेजरिङ कुर्टोसिस भनेर लेख्दैछौँ है त। मेथड्स अफ मेजरिङ कुर्टोसिस, पर्सेन्टाइल मेजर, पर्सेन्टाइल मेजर अफ कुर्टोसिस, पर्सेन्टाइल मेजर अफ कुर्टोसिस, मेजर अफ कुर्टोसिस, measure of kurtosis, measure of kurtosis based on moments. Okay, measure of kurtosis based on moments. So first we are going to start with the percentile measure of kurtosis. Percentile measure of kurtosis. Okay, so let's write here one number. Percentile measure of kurtosis, percentile measure of kurtosis. Okay, यो अब percentile measure of kurtosis भनेको यसमा चाहिँ हामी के भन्छौँ त, the measure of kurtosis, the measure of kurtosis based on quartiles, and percentiles, based on quartiles and percentiles is called percentile, is called percentile measure of kurtosis, is called percentile measure of kurtosis. Okay, अब हामी यहाँ लेख्दैछौँ फर्मुला percentile coefficient of kurtosis भनेर लेख्छौँ है त. Okay, percentile coefficient of kurtosis. Kurtosis भनेको यसलाई हामीले सिम्पली के ले डिनोट गर्छौं. Percentile coefficient of kurtosis भनेको just you have to denote it by k. Percentile coefficient of kurtosis भनेको के, यसको फर्मुला हुन्छ Q3 minus Q1 divided by 2P90 minus P10. Okay, Q3 minus Q1 divided by 2P90 minus P10. यो percentile coefficient of kurtosis. यसलाई हामी के भन्छौँ त, percentile coefficient of kurtosis. यसको फर्मुला हुन्छ Q3 minus Q1 divided by 2 bracket P90 minus P10. Okay, ल अब यसको पनि हाम्रो के हुन्छ त, interpretation हुन्छ. So that we are going to write here. Interpretation of calculated value of percentile coefficient of kurtosis. Interpretation of calculated value of percentile coefficient of kurtosis. Percentile coefficient of kurtosis. Interpretation of calculated value of percentile coefficient of kurtosis. Okay, so now let's write here in. यसको हामी I number मा लेखौं. यसमा चाहिँ if k equals to k को भ्यालु चाहिँ exactly 0.263 आयो भने, if k is equals to 0.263, then the curve drawn from the distribution, curve drawn from the distribution of data is mesokurtic. Okay, if k equals to 0.263, then the curve drawn from the distribution of data is mesokurtic. Okay, on the basis of the same number is 0.263 मा हेरौं if k को भ्यालु चाहिँ के भयो k को भ्यालु चाहिँ greater than 0.263 आयो भने then the curve is left to kurtic. Okay, then the curve is left to kurtic. Now in third number, if k is less than 0.263, then the curve is platykurtic. Okay, so this is the interpretation of calculated value of percentile coefficient of kurtosis.